meeting is being recorded.
Uh, disclaimer.
Uh-huh.
Uh, it seems like there was no video for yesterday's class. We didn't see any video. We trying to catch up. There was no video for yesterday's class.
I probably forgot to upload it. I'll upload it after this. Hold on.
Oh, okay.
Let me double check. Yeah. Yeah, I just need to upload it. Okay. David, can you read this one?
I wasn't here yesterday, so I need to catch up from yesterday's classes.
Okay. Tim, can you read this one?
Yes. Good afternoon, everyone. Tuples. Tuples are very similar to lists, except that they are immutable. They cannot be changed. Also, they are created using parentheses rather than square brackets. Example, you can access the values in the tuples with their index, just as you did with lists. Try yourself. Try to reassign a value in a tuple causes a type error. Like lists and dictionaries, tuples can be nested within each other. Thank you.
All right, so similar to lists, you've got tuples. Tuples are often auto-generated by Python. I'm trying to think when to give a good example. I can't think of one right now, but anyway, generally I use lists. I don't make tuples, but tuples are immutable, and again, immutable means they can't change. So, all right, go ahead, answer the next question. Okay, fill in the blanks to create a list. A dictionary and a tuple. So we got lists, dictionaries, tuples. Brian, can you read this one?
Tuples. Tuples can be created without parentheses, just by separating the values with commas. An empty tuple is created by using an empty parentheses pair. Tuples are faster than lists. They can't be changed.
Okay. So go ahead and work on the practice problem and raise your hand when you're done.
Hey, Brandon, question. When you use the multiply sign, it means all, with import all, right? So what happens when you have two of them to a number?
You mean,
The
well,
multiplying sign, the asterisk.
it also means times.
When you have
So
two of them, it's times.
if you
Or
have
when you
like a
have
number after it, it's like doing
multiplication.
n- no, it's
Exponents, isn't it?
yeah, exponents. Yeah, thanks.
Yep.
Okay.
I couldn't think of the word. You know,
So when you
have,
have
like
when
the
you have a
little,
word,
like if you have times 2, it's like squared. You know what I mean?
oh, okay, like the square root of 2. That's what it's
No,
saying.
squared. Like, okay, so like 3 squared would be 3 times 3.
Right. Okay.
Yeah.
Cool.
I don't think the code is so much the problem on this one. I think I'm just not tracking on the math it needs to get the right output.
Yeah, this one has a lot of math in it, which is not usual. You're not usually gonna have to be doing a lot of math, but the key is really to focus on that bottom yellow part, right? That says exactly what to do. And if you need to look up and actually Tim, by asking that question, made a good point of the 2 times symbols is the way to do squared, right? Or well, if you put a 2, okay, it's to do exponents. But like right there with the question, plus the square of the vertical. So that's a sign you're gonna use that.
Oh, okay. Yeah, I think I can
Yeah.
get that.
Yeah.
Thanks.
Uh-huh. All right. Looks like a lot of you are done now, but let's do something a little different. For people who are still struggling, who wants to volunteer to be screen share person, and we can walk you through what to do. So the people who haven't figured it out, who wants to be the screen?
Brandon, I think I want to do it just because I have a working result, but I'm off by like a portion of the percentage, and it just doesn't make sense to me. So I'd love to help. Just see what I'm
Okay.
doing.
Sure. Do screen share.
Yeah. All right. So
Oh, you didn't square the first one. You squared. So you have to square each one. You're like squaring the answer, but you need to square the P10
square
minus.
the grid points individually.
Yeah, the P10 minus P20. Once you get that answer, you square that, and then you square the answer to the second one too. So like,
Right.
well, you could leave that. That was fine.
Maybe I'm not tracking. Do you want to break it down
Yeah.
for me?
So move your um. So move your cursor to the left, or the not cursor, but your little flashing line thing.
Yeah, we're at.
Uh, right after the tuple for the P10 minus P20. So like right over a little too far. Over one more. Sorry, over to the right more. My bad. Okay, then square that.
I'm not sure what you mean when you say square that. So
Oh,
I know.
just like the times two you did right there. Good. And then do the same thing for the other one, but get rid of that times two at the end. I think you deleted a tuple. Yeah. Go ahead and add your I think you need to add another one.
I get lost in
Yeah.
these. Jeez.
Yeah.
Um.
Try adding another one at the end.
So 4 on the end.
Yeah. Because you got 1, 2, 3. You got 4 in the beginning, so that's why I was thinking you'd have 4 in the end. Of course, wait. One of those is okay. Yeah, never mind. You'd have 3, so delete that one.
Oh, there we go.
There
Okay.
you go. All right. Anybody else who's still struggling, have any questions on this one? This one was definitely a more mathy one than usual. Usually with programming, you're not gonna have to do this much math. It's mostly just like variables and loops and stuff. Um, but occasionally you will. But no questions. Okay. Well then, moving on. Okay. What is the result of this code? We want tuple 1. Well, the tuple 0 is this, and so tuple 1 is this tuple inside a tuple. Right. Kevin, can you read this one?
List slices. List slices provide a more advanced way of retrieving values from a list. Basic list slicing involves indexing a list with two colon-separated integers. This returns a new list containing all the values in the old list between the indices. Like the arguments to range, the first index provided in a slice is included in the result, but the second isn't.
All right, so if you just want part of your list, then you can do a list slice. So like 2 to 6 is going to be 0, 1, starts on 2 and goes to 3, 4, 5, and then ends on 6. So it's not going to include the 6th one, and so on and so forth. So any questions on that? Okay. I've generally never needed to do a list slice or anything, but good to know. Oh, darn, I gave it away. Well, this one, get from 4 to 7, 0, 1, 2, 3, starting on 4, 5, 6, doesn't include 7. Roger, can you read this one?
List slices. In the first number in a slice is omitted, it is taken to be the start of the list. If the second number is omitted, it is taken to be the end. Example, slicing can be done on tuples.
Okay. Any questions on that? So that's going to be 0, and that's going to be just go all the way to the end. Okay. All right. Jacob, can you read this one?
I kind of missed the answer before. List slices, fill in the blank. First two elements of the list.
The colon and
Oh,
2.
2. Okay. Thank you.
Jacob, can you do this one?
Yes. List slices. List slices can also have a third number representing the step to include only alternative values in the slice. 283 will include elements starting from the second index up to the 8th with a step of 3.
So like a step of 3. So like with this one, this first one, the step of 2, right? It's saying from the beginning to the end by 2s. So like 1, yeah. So like 2, 4, 6, like that. And this one saying from 2 to 8. So 0, 1, 2, 2, 3, 4, 5, 6, 7, 8. So to this one by 3s. So 1, 2, 3, and wait, no, that's by 2. So 1. So and then to this one, I think that's all that's included. Let's see. Yeah, it's just those two included. Any questions on that?
So list slicing is counting the number by that ratio set. Like if it's a colon 2 or 2 colon 8, it would the 2 would represent the beginning and the 8 would represent the end, or the 3 would represent the end.
No, yeah, the first two are where in the list you're slicing the list, and then the final number is by how many steps, if you include a final number. You don't have
And
to
you have to
include a final
count 0, 1, 2, 3, 4, 5 with 0 starting off, right?
Yeah.
Okay, great. All right, thank you.
Okay, go ahead, answer the next question. Okay, what's the output of this code? So you want start with the first one, so 0, 1, and then it's saying it doesn't have a second number, so go all the way to the end. But then count by fours. So 1, 2, 3, 1, 2, 3, 4. 1, so we got 25, and then 1, 2, 3, 4. We got 81. All right. So, Patricia,
How did you get 81?
what was that?
How did you get 81?
So by counting by fours. Okay, so this right
So
here.
you counted 0. Did you count 0?
Well, no, the first one. See, there says there's a 1 in the beginning, right?
Right.
And then so that's your starting number. So 0, 1, right? And then there's no second number. So that means, so if there's no first number, it start at the beginning. If there's no second number, it's go all the way to the end, right? And then the 4 is count by fours. So we're starting on this one, so it's going to include this one, and then counting by fours. So 1, 2, 3, 4 gets us to 25. And then by fours again, 1, 2, 3, 4 gets us to 81. Does that make sense?
Okay, so although the starting number is 1, basically you are counting from 1. 1, 2, 3, 4, 1, 2, 3, 4. You're not really counting 0 as a starting number.
If
because it goes from 1. Okay, so 1, 2, 3, 4, I'll end up at 25. 1, 2, 3, 4, I'll end up at 81. Is that how it goes? Because you're not really counting the 0 for the start, and it's not a 0, it's a 1, correct?
Well, oh yeah, only because this 1 is here. If this 1 wasn't here, then it would start at 0, and then
exactly at 0. Okay.
And then by fours it'd be 1, 2, 3, 4. So we'd be at the 16. But since the 1 is there, it's saying our starting number is 0, 1. Yeah. Does that make sense now?
It makes sense. So the squared area means that it's double that. So that's why we had to count for 4 at the end to get to that 81 and not just end up at 25. So it's 1 and 4. So my question to you is, why didn't we stop at 25 and we had to continue to make count another 4 to get to 81?
Because see this. Okay, so the first one is our starting
number.
Oh, the second
I get
one,
it, because we are looking at the parentheses is what we're looking at. If we count it from the 1 and the 4, then we're going to end up at
yeah, this is what we're looking, because this is what's printing to the screen, right? And so it's doing a list slice, because this is a list, and then when it adds the colons, that's a list slice. But since there's no number in between those colons, like normally you'd have 3 numbers, right? But if you don't put a third number here, or if you don't put a number in between the colons, then that means go all the way to the end. For your
Okay,
list
so
slice.
so what if there was no 81 down there and in the answers? What if there's no 81 there? Would that make
Well, then
sense to just stop at 25?
yeah, it would have stopped at 25 if it only
Gotcha.
went to 64. Yeah,
It would have stopped at 25, right? Not 64.
right,
If there's no 81 there. Okay.
right. Okay,
All right.
so Patricia, can you read this one? Or did you just read?
No, I can read it.
Okay.
List slices, negative values can be used in list slicing and normal list indexing. When negative values are used for the first and second values in a slice or a normal index, they count from the end of the list. If a negative value is used for this step, the slice is done backwards using double colon -1 as a slice is a common and idiomatic way to reverse a list. List slices, write a program that takes a list as input and outputs the last element of that list.
So the easier way is to use the function reverse instead of doing that. But anyway, okay, go ahead, get started on this and raise your hand when you're done. Okay, a lot of people are done. So Samantha, can you do share screen and share your answer?
Yeah.
Are you sick or just getting over being sick?
Just getting over.
Oh, okay, never mind. Don't worry about it. Okay. Let's see who hasn't gone. Sandra. Oh, wait, are you still working on it, Sandra?
No, I'm done. I just
Oh,
loaded
okay.
my hand a second ago.
Oh, okay. Can you do share screen, please?
Of course. There you go. So it's actually pretty easy. Print in parenthesis elements, -1 in the bracket, and that was it. It worked.
Good. All right. So anybody struggling on that one or need help? Yeah, so that's the same thing as doing, well, what I did was I didn't do their way. I just did it the way I'd probably do it. It's the same as getting the length of it using len and then minusing 1. But their way's faster. But anyway. Okay, what is the output of this code? So we've got 5, we want from 7 to 5. So 0, 1, 2, 3, 4, 5, 6, 7. There's our starting 1, 2, 5. And so that's going backwards. So to here, but it doesn't count this last one, and it's going reverse, so that's why it gets the 36. All right. And Will, can you read this one?
I sure can.
Thanks.
List comprehensions are useful the ways of quick creating lists. Those contents obey a simple rule. For example, we can do the following. List comprehensions are inspired by setting builders notions in mathematics.
Okay. So let's do this one. So we've got I times 3, and then for I in range 5. So, or sorry, it's not times, but square or cubed.
Exponent.
Yeah, but to the 2 would be squared, to the 3 would be cubed. So, and then for I in range 5, so we've got 0, 1, 8, 27, 64. So the first one, it's gonna be I is gonna be nothing, right? And then second one, okay, it's 1. Where do we get? Hold on. A simple rule. Well, let's go on and see more about this one, because I don't really remember this one. What does a list comprehension create? A list of even numbers between 0 and 18. Okay.
It's because it got multiplied by 3. Try yourself. 0 and 1. And I don't know how they got 8. It might have been 5 plus 3, but then it was 3 times 27, and 3 times 27 equals 81. Never
What
mind.
it is it's to the power. So 2 to the 3rd power is 2 times 2 times 2.
Yeah.
And then it goes on to 3 times 3 times 3. And that's
Right.
where the range 0 to 5 is.
Right.
Well, there you go. Thanks, guys. Is it Fred? Ayani, can you read this one?
List comprehensions. A list comprehension can also contain an if statement to enforce a condition on values in the list. Example, run the code and see how it works.
Okay, so you've got your list comprehension, right? So let's see what that look like without it. Okay, so we've got in your range 10. So looks like it's iterating through. So 0, so I is 0, I is 1, then I times 4, and then where are they getting?
This one is raised to the second power, so 0 is 0 times
Oh.
0, then 1 times 1, 2 times 2, 3 times 3.
Okay. Yeah, 3. Oh, okay. So I is now 3, so 3 times. Okay, now I get it.
Yeah,
And
4
then
times.
and then 4 times 4. Okay. Okay, cool. Thank you.
Yep.
Wasn't getting that. Okay, so there you go. That's with just by itself. And then so we're saying if I times 2 divided by or not, yeah, no, not divided by floor 2 equals 0. So if it's a, I guess it's saying it's only going to print if it is divisible by 2. So we're only left with 0, 4, 16, 36, 64, because if we get rid of this, like 1's not divisible by 2, 9 isn't, 25. So it's only giving you the even numbers by adding that if statement.
Right.
Any questions there?
That would help.
All right. So go ahead, answer the next question. Okay, create a list of multiples of 3 from 0 to 20. So for I in range 20, or I for I in range 20, and then if it's divisible by 3 equals 0, so it is divisible by 3, it's only going to print the multiples of 3. Okay. Mark, can you read this one?
Trying to create a list is a very extensive range will result in a memory error. This code shows an example where the list comprehension runs out of the memory. The issue is solved by generations, which are covered in the next module.
All right. So go ahead and start on this and raise your hand once you're done. All right. Looks like a lot of you are done now. So, Roger, would you mind doing screen share and sharing your screen? Good. Yeah, so what he's doing here, oh, actually, I'll let you explain it, Roger. You're muted.
Just created a list, used I for I in the range, and then the percent of 5 equals 0, and I percent 3 equals 0. Then you put the list.
Yeah, so if it's divisible by 5 evenly, and then if it's divisible by 3, so good go. All right. So moving on. Oh, and for this last one, fill in the blanks to create a list of numbers multiplied by 10 in the range of 5 to 9. So x times 10 for x in range 5 to 9. All right, that's a good place to stop for the day. So let me stop screen share and I will be right back.